when the angle between conductor and flux is 0, then there will be no flux cutting. When there is no flux cutting, EMF induced in the conductor will be 0. So, EMF 0 and current will be 0. Second, when we move conductor from 0 degree to 90 degree, if we turn the shaft 90 degree clockwise, then flux cutting is increasing, and at 90 degree angle flux cutting will be maximum. So, from 0 degree to 90 degree flux cutting is increasing. When flux cutting is increasing, EMF induced will also increase. So, at 90 degree the flux cutting will be maximum. So, from 0 degree to 90 degree EMF induced will increases from 0 to maximum. Now, if we give further 90 degree rotation, that is from 90 degree to 180 degree, then flux cutting start decreasing. When the flux cutting start decreasing from the maximum value, EMF induced also start decreasing from maximum to 0. At 180 degree the flux cutting is 0. So, at this position EMF induced also 0. So, in these two diagram, this black conductor was rotating in the influence of north magnet. Here you can see from this to this, black conductor is rotating in the influence of north magnet, white conductor is moving in the influence of south magnet. Here also black conductor is moving in the influence of north magnet, and white under the influence of south magnet. Now, if we give further rotation, that is from 180 to 270 degree, now the flux cutting again start increasing from 180 degree to 270 degree, but in this position now the white conductor is moving under the influence of north magnet, which was previously moving under the influence of south magnet. So, in this position flux cutting increasing from 0 to maximum, but in the negative directions. If we give further rotation, that is from 270 to 360 degree, again white conductor is moving under the influence of north, black under the influence of south. Again flux cutting start decreasing from maximum to 0, and EMF also decreasing from maximum to 0 in the negative directions. So, what we concluded that from 0 to 90 degree flux cutting increasing, EMF inducing increasing in the positive direction. From 92 degree to 180 degree flux cutting decreasing, EMF induced decreasing from maximum to 0, but in the positive direction, positive side. After 180 degree flux cutting increasing, EMF increasing, but in the negative directions, and between the angle 270 to 360 degree again flux cutting decreasing, EMF decreasing in the negative direction. So, what we concluded, these are the different angle positions of the conductor. First is at 0 degree position. At 0 degree position, first observe the meter direction. At 0 degree meter is indicating the 0. At 180 degree meter indicating the 0. At 360 degree meter indicating the 0. 0 degree 0, 180 degree 0, 360 degree 0. Now at 90 degree meter is indicating in the right hand side. At 270 degree meter is indicating in the toward the left side. So during the 0 to 90 degree EMF is in the positive direction, and 182 to 360 degree EMF induced in the negative directions. Okay, now we will discuss the elementary DC generator. So far we have discussed the AC generator. Since DC generator must produce DC current instead of AC current, a device must be used to change the AC voltage produced in the armature winding into DC voltage. This job is performed by the commutator. To convert the AC into DC, what we will done, we will replace the slip ring with the commutator. The commutator is constructed from a copper ring split into segment with insulating material between the segment. Brushes riding against the against the commutator segment carry the power to the outside current. Commutator in the DC generator replace the slip ring of the AC generator. This is the main difference in their construction. The commutator mechanically reverse the armature loop construction to the external circuit. So at 0 degree the EMF induced 0, at 90 degree EMF induced maximum, at 180 degree EMF induced will be 0. That is from 0 degree to 90 degree flux cutting increase, EMF is increasing. 90 to 180 degree flux cutting decreasing, EMF induced decreasing. Now after 270 degree in the AC generator, flux cutting increases in the negative direction, but with the help of commutator we will reverse the direction of flux cutting and EMF induced. Now the EMF will induced in the positive directions. During the this time, however, the conductor that previously cut the south magnetic field is now cutting the flux lines of north field and vice versa. We will change the flux cutting of this armature conductor. Since these conductors are cutting the lines of flux of opposite magnetic polarity, the polarity of induced voltage is different for each of the conductor. The commutator, however, maintains the correct polarity to each brushes. The conductor cutting through the north magnetic field will always be connected to the negative brush, and the conductor cutting through the south field will always be connected to the positive brush. Since the polarity at the brushes has remained constant, the voltage will increase to its peak value in the same directions. So what we will observe from DC generator at 0 degree, at 180 degree and at 360 degree, EMF induces 0. At 90 degree, from 0 to 180 degree, EMF induced is in positive directions, and from 180 degree to 360 degree again EMF induced is in positive directions. So with the help of commutator we have changed the direction of EMF which was previously in the negative direction to the positive side. The actual practical DC generator. The actual construction and operation of a practical DC generator differ somewhat from our elementary generator. Nearly all practical generators use electromagnetic poles instead of permanent magnet used in our elementary generator. The main advantage of using electromagnetic poles are increased field strength and possible to control the strength of field by varying the input voltage. the field strength is varied. By varying the field strength, the output voltage of generator can be controlled. So types of DC generator: self-excited DC generator, separately excited DC generator. Self-excited DC generator can be further classified as series generator, shunt generator, and compound generator. First is separately excited generator. In separately excited DC generator, field winding is excited from the separate source. These are generators whose field winding are excited from some external source or supply. The flux produced by the field poles depends upon the field current within the unsaturated region of magnetic materials of the poles, but after saturation the flux remains the constant. So the following relation will be derived from this separately excited DC generator diagram. That is, first is IA is equal to IL. IA is the armature current, IL is the load current. So both are connected in series, so IA will be equals to IL. Because in the series connections, current remain the same throughout the circuit. These are connected in series, so these current will be same. And EG will be equals to V, this V plus IA RA. EG, that is generated voltage, will be equals to V plus voltage drop across this armature resistance. Also we can write it as EG is equal to V plus IARA plus 2VB. This 2VB is representing the voltage drop across these two brushes. We multiply this VB with 2 because in the generator we are using the two brushes. Self-excited DC generator. In self-excited DC generator, field winding is excited from the this armature armature of the generator. So in self-excited, no external source is required. The excitation of this field is done with the help of this armature. These are generators whose field winding is energized by the current supplied by their own armature. So the field winding is energized from its own armatures. Due to some residual magnetism, some of the flux is always present in the poles. When the armature is rotated by means of prime mover, EMF and hence current is produced. The current passes through the pole coils partially or fully and thus strengthen the residual pole flux. In a self-excited DC machines, the field coil may be connected in series with the armature, in parallel with the armature, or partially in series with the and partially in parallel with the armature. Next is DC series generator. In DC series generator, the field coils are wound with a few turns of thick wire as shown in figure and are connected in series with the armature. Therefore, the full lines current IL or armature current IA flow through it. Before the machines will excite, the external circuit must be closed. So in the series field winding, these relations will be can be derived. First is these are connected in series, so ISC, IA and IL, all the current will be equal because they are connected in series, and AG will be equals to V plus voltage drop across armature resistance plus voltage drop across this RSE. DC shunt generator. In DC shunt generator, the following relation can be derived, that is, armature current IA will be equals to I shunt plus IL. If you apply Kirchhoff current law here, then at this node, incoming current is IA and outgoing current is I shunt and IL. So this relation can be derived, and EG will be equals to V plus IARA plus 2VB. Next is DC compound generator. DC compound generator are of two types, short shunt and long shunt. DC compound generator, short shunt, and this is a long shunt. Same way DC motor can be classified as self-excited DC motors and separately excited DC motor. Self-excited DC motor can be further classified as series motor, shunt motor, compound motor. So, same way separately excited DC motor, in separately excited DC motor, field winding is excited from the external source. In self-excited DC motor, the field winding will excite from their own armature.